right, perfect. All right, so I'm sure people are going to continue to join us, but we'll get going. So, hello, everybody. Welcome to the final day of our IPM week. Thank you so much for being here today. And also, if you've attended other webinars this week, thank you for joining those. We hope that you've enjoyed them as much as we have. It's been quite an informative week. My name is Kelly Damon. I'm a research specialist at UVM Extension with the Northwest Crops and Soils program with Heather Darby. I work on many of the projects involving pest and disease management and various cropping systems, including one of the topics we're going to discuss today about neonicotinoids. So I just want to remind everybody, Shannon put up a list of all the topics we've discussed this week. So all of these will be on the UVM Extension Northwest Crops and Soils YouTube page in case you missed any or want to view them again. You'll have access to those. Maybe Shannon could share a link so you can just keep your eye out for those. I want to thank both Shannon McDonald and Susan Brulette from the Northwest Crops and Soils team. They've been a huge help this week, making sure that the webinars run smoothly. And making sure that all of these webinars will get posted so you can visit them. So to wrap up our wonderful week of IPM, we will be hearing from Dr. Katja Poveda from Cornell University, as well as Dr. Heather Darby from UVM Extension. They'll be discussing some updates on the current research regarding early season pest management and neonicotinoid use in both Vermont and New York, and helping us understand the risks associated with management practices as we approach this ban on neonicotinoids. So as many of you might be aware, the state of Vermont recently passed Bill H706, which will ban the use of neonicotinoids beginning January 2029. And experts in both states have been working hard to understand how this legislation could affect the pest management practices on farm. So to discuss this with us today, we have Dr. Katja Poveda. Dr. Poveda is an associate professor of entomology at Cornell University, where her program's research focuses on plant-insect interactions and how they shape key ecosystem services in agricultural systems. She studies how plant and habitat diversity, along with land use changes, can affect insect biodiversity, with a long-term goal of developing more sustainable management practices that can be targeted at different scales in the agricultural operation. We'll also, after Dr. Poveda, we'll hear from Dr. Heather Darby, who many of you are familiar with, to discuss what's happening in Vermont and the research surrounding neonicotinoids here. Many of you know Heather Darby as an extension agronomist and soil specialist, and her work focuses on sustainable agriculture and environmental stewardship, and making sure all of this information that we collect is very accessible to Vermont growers and those involved. So I just want to, Shannon, if you'll go to the funder page. Thank you. I just want to take a moment before we dive right in to thank all of our funding sources. They have made this research possible. So thank you to One Hive Foundation, the Vermont Agency of Agriculture, the Northeast Extension Risk Management Education Program, and the USDA National Institute for Food and Agriculture. We will have CCA credits available at the end of this webinar. Shannon will post this page again for you to scan the QR code. You can also send your information to Susan Brulette. And we will also have pesticide applicator credits available, and you could share that information with Shannon McDonald. We'll post those again afterwards. So I'm going to turn this over now to Dr. Poveda. If you do have any questions, feel free to put them in the chat. We'll have a little Q&A session at the end of this. And it's all you. Thank you so much for being here.
Thank you so much for having me. I hope you're all seeing the presentation, just making sure that that's working. Good. Perfect, excellent. So yeah, thank you to all the organizers for having me. So I'm Katja Poveda. I'm from the entomology department at Cornell University. And I will be talking about early season pest damage across New York and the risk under different management practices in light of this neonicotinoid ban. And I'm going to start with a very general background, if I can make this work. Perfect. 1 second, I'm sorry. I'm just going to get my things in order. Perfect. Okay. So I want to start with the explanation of what are neonicotinoid insecticides. So they were insecticides introduced in the 1990s. They are systemic insecticides, which means they are absorbed by the plant tissue and move through the vascular system of the plant. So it moves into the leaves, it moves into the flowers. They're highly water soluble. And so if they're applied to the soil, they can be taken up by the plant when they're taking up water. And it's the most widely used insecticide in the world. And they target a large range of important insect pests. For some reason, this is not perfect. So the most common neonicotinoids that we're using are clothianidin, imidacloprid, and thiamethoxam. And they're used as seed coating. And in the US, the majority of corn and soybean seeds are planted with this neonicotinoid seed treatment. And they are used to treat against pests like seed corn maggot, wireworms, white grubs, or corn rootworm. But their usual usage is controversial. First, because it has limited evidence of economic benefit, and this is for field crops, not for vegetables, not for potatoes. We're talking about field crops here, and the environmental risk is really big to non-target pests. So if we look at the neonicotinoid treated seed, so if this would be a corn seed treated with neonicotinoids, what is important is that most of this treatment goes actually into the water, into the soil, and it's just 2 or 3% that is taken up by the plant, and the rest is lost to dust, to waterways, or to the soil. And what is also important is that the benefits in terms of yield have been shown to be for less than 5 to 8% of fields. The other reason that they have been so controversial is that when in June 2020 in New York State, they did a risk-benefit analysis of using these neonicotinoid insecticides, focusing on the risk to pollinators. They found that the economic benefits to the users are actually not great for field crops. And that is the reason why New York State moved ahead and started the Birds and Bee Protection Act that was signed by the governor in December 2023, and it will prohibit the sale, use, or distribution of any corn, soybean, or wheat seeds coated with neonicotinoids starting January 1st, 2029. And so because of this bill, Cornell Integrated Pest Management started this project to look at neonicotinoid alternatives for the state. And before I move forward and tell you what we have done, I just want to introduce the team. So Alejandro Calixto is the director of Cornell IPM, and this is the extension team that has been working with us. There's a lot of people from my lab that have been working with us. New York State Agriculture, Ag and Markets give us the funding, and the USDA. And I also have to thank more than 60 growers in the state that have been actually working with us. So in the light of the Bird and Bees Protection Act, what we were tasked to do is to look at the risk of early season pest damage in field crops in New York. So first is, which are those early pests? How can we effectively monitor them? Can we predict where and when they occur? And how high is the damage caused by these pests? And so we also wanted to know to what extent the pest pressure is shaped by local management practices, which is also very important. So we know, and this has been very clear from the beginning, that the main early season pest is the seed corn maggot. It is a fly. It has a global distribution. It will overwinter as pupa, and then very early in the spring they emerge, they will lay eggs, those larvae will hatch, and then they will pupate again, and during the summer we'll have 3 to 5 generations that will happen during one growing season. We know that it feeds actually preferentially on decaying plant and animal material, including seeds, and it can become a pest of corn, legumes, cucurbits, and others, which is, why we're talking about them. The larvae can feed on the seeds before and during germination, and these seeds are favored in cool and damp conditions. So the longer the seeds are sitting in the soil when it's cold and wet, the more attractive they become for this pest. When there's stand loss, it is patchy and sporadic, and because there are no rescue options, the only option is prevention or really understanding much better this pest. So we started with monitoring adult abundance, like how do we want to do the monitoring? And we started this in 2022 before the bill was even signed, because we knew that this was coming, so we wanted to prepare. So one of the ways that we monitor most of the insects are these yellow sticky cards, but there were some reports that blue sticky cards were actually better. So we set up sticky cards at 79 sites, so all these different sites here across the state, to see which ones are more effective. And the answer is super clear. So total abundance of adults is highest in blue sticky cards than yellow sticky cards, and that is true for females, it's true for males, and it doesn't matter which site you look at or what time in the year, you will always find these effects. So from this part, there's a clear recommendation that if you want to monitor the adults, you should be using blue sticky cards. So then we wanted to know how widespread are these seed corn maggots in New York State, and how much damage are they actually causing in the States. So in 2023 and 2024, we monitor more farms, so 54 in 2023 and 40 in 2024. And yeah, these blue cards are the position of the blue sticky cards. And we found several things. So this is the weekday. So it is the 10th week of the year, the 15th week of the year. So we monitor them throughout the year. And we find that in March already, we see the first emergence of flies. So initially the thought was that they would be emerging at some point in May, and we could be planting earlier than emergence, but actually that is not true. We have the first emergence happening at some point in March, and this is much earlier. It's almost 10 weeks before we have our first planting date. So this green arrow here is our average planting date. So we know that the adults are out and the populations are actually really strong by the time we're planting. We also know that the adults are present at all sites all the time from April to November, consistency, that the emergence occurs before planting. And so we wanted to obviously know how big is the damage. So we know the adults are present everywhere all the time. And so in addition to the blue sticky cards where we see these yellow dots, we had these wire mesh traps, which is basically a wire mesh. It includes 10 seeds of corn or 10 seeds of lima bean, and we're using lima bean here because it's very attractive to this larvae, just to have like a maximum population abundance. So the first question that we wanted to ask is, can we predict the number of larvae and pupae that we find in this wire mesh, in the seed, based on the number of adults? And we can't. So we find that there's high population of adults present, but that is not necessarily matched with a high population of larval present. So those two things are completely independent. So we cannot use adult monitoring to predict what is happening in the soil. The other part that we found is if we're looking at damage risk and we look at how many larvae and pupa of seed corn maggot we're finding in the field, those numbers are really small. And so what this means is that we're finding 6 to 7 seed corn maggot larvae and pupa per 1,000 seeds. Yes, so this is per trap, which includes 10 seeds. So for corn, we have basically 6 to 7 larvae and pupa in 1,000 seeds. The same is true for soybean, and just lima bean has has a higher amount, but these are our target crops. If we look at the proportion of seeds damage, again, those are extremely low, meaning that there's just 2 to 3 seeds damaged per 1,000 seeds. So the damage risk that we're finding is extremely low. And we wanted to do a damage, like a prediction of where the damage is the highest in the state. And because we just have zeros, basically, we cannot really do a predictive model. So it was clear that we need larger scale data from the field to be able to capture like more damage and more larvae. So that's why we started in this year an experiment where we're sampling across 56 farms over the next 3 years, starting this past 2025. And we're working with field corn, soybean, and we have a few plots of sweet corn and snap bean, but I will not be talking about those today. And so the idea is that if a farm is participating in this 3-year study, there's 1 acre plot that is treated with neonicotinoids and fungicide, and 1 acre plot that is just treated with the fungicide and not the neonicotinoid. They're growing next to each other. We provide the seed, but each grower will decide the planting date and all the management practices. So we are not interfering and deciding on any of the management that the grower are doing. So for the fungicide, just for those interested, these are the 6 fungicides that are on the seed. And the neonicotinoid that we're using is this fungicides plus thiamethoxam. So this is our methods. So 1 acre was planted with treated and 1 acre with untreated seeds. 7 to 9 days later, the seeds were dug up and dissected for seed core maggot larvae and pupa to see how many seeds were damaged. Then during VE and V1, there's pest scouting to look at pest scouting and stand loss count. And during V3 and V4, again, we do pest scouting, stand loss counts, and we measured fresh biomass just to see how the plants were growing. And then at harvest, the yield in the 1 acre plot versus the other 1 acre plot was measured. So what did we find? So here I'm presenting the average seed core maggots per seed. And for field corn, where we have 33 sites, we don't find a significant difference. However, for soybean, we find that treated seeds, so neonicotinoid seeds, have less abundance of seed core maggot. What is important here is that these numbers are still 6 maggots per 100 seeds. So most seeds are completely undamaged. But if we look at the at the stand count, and we look at field corn and soybean, we don't find a significant difference anymore. So the stand count in both of these cases are exactly the same. And if we move into yield, we also don't find any difference. So this is for field corn. This is the neonicotinoid treated seed and the untreated seed. There is not a significant difference between these two. If we look at grain, like field corn for grain, we also don't see a difference between the treated and the untreated seed. And if we look at the yield for soybean, again, the treated, neonicotinoid treated and untreated seed are not significantly different from each other. So our preliminary results are suggesting that neonicotinoid seed treatment reduces the abundance of early seed core maggot in soybean. However, the seed core maggot pressure is very low, and the neonicotinoids are not providing a benefit in terms of stand counts or yield. So although we see a few more seed core maggots in the untreated seed, there is no effect on stand count or yield. So right now, from the data we have, and again, this is just our first year of data, there seems to be no cost in removing neonicotinoid seed treatments in terms of stand loss, biomass, and yield for field crops. However, and this is super important, we did not capture damage rates for early planting. And this is important because, as I mentioned at the very beginning, like these cool and damp conditions are the ones that seem to be very attractive for seed core maggot, and I will be showing data for that in a second. So we had a survey out for damage reports. So people, like growers in the region that have found that they have seed corn maggot. And we just had 5 reports that have a verified case of seed corn maggots. It's a combination of field corn and soybean. These were planted in April to mid-May. We have a few counties that were affecting, and in 3 out of the 5 cases, replanting was necessary. What is also important to say is that in all these cases, the seeds were treated, yes? So we had 2 cases, 3 cases where they were treated with Cruiser Max, so they are protected with the neonicotinoid, and 2 cases where they are treated, but they didn't tell us what the exact product is that they used. So we know that these wet and cool conditions can be driving seed corn maggot damage regardless of the seed treatment. So the neonicotinoids are not preventing that damage, but we need more data here, and we will try to do this coming field year to have earlier plantings to be able to capture how much the stand loss and the damage could be. Okay, so we looked, because we have all this adult data, which factors will be predicting adult abundance, and we found that weekly temperature, rainfall, soil characteristics, but also the amount of corn that is surrounding the farm is important and will increase actually the adult abundance. But then also management practices such as cover crop and manure are influencing adult abundance. As I mentioned at the beginning, adult abundance and larval abundance are not necessarily correlated. So we wanted to see what happens with these management practices below ground. So are we seeing also more damage? So these are just the data from the adults. So if there are cover crops, we have more adults. And now we wanted to see if that is translating into damage. So if we look at the literature, the extension literature, it's very clear that it says that the seed corn maggot, the pest, is closely associated with organic matter such as manure and plant residues, that the females will seek fields with high organic matter like manure and cover crops, that the females will lay eggs on degraded organic material in soil cracks and especially in manure piles. So we wanted to see if we do an experiment, what would happen? And so I'm going to present some data from one of my former students, Anna Di Paola, that worked with growers to have one part of their farm with no cover crop and one part of their farm with cover crops. And she crossed these cover crop treatments with seed treatments. So one of the treatments was the fungicide, one the neonicotinoid, that is basically the fungicide plus the neonicotinoid, and a diamide and neonicotinoid combination. So this is how the experiment will go. So half the plot has no cover crops, half has cover crops, and then it's crossed with these seed treatments. She did this at 25 different sites over 2 years. And these were the cover crops used in 19 of those sites. They had dry cover crop, and 6 they had the wheat cover crop. And these are the results. So here you can see these first 3 bars are the cover crop. These 3 bars here are no cover crop. And these are the different seed treatments. And basically there's no significant difference across the board. Like there's not an increase damage in cover crops, but also the seed treatments are not necessarily different from each other. So yes, they're not more protective. And again, it's super important to highlight how little damage we're finding. It's just 1 seed was damaged out of 100 seeds on average in this case. If we look at the yield to see if somehow the presence of the cover crop or those different seed treatments translate into yield, we don't find any significant differences again. So these were the results on cover crops. So what about manure? Do we see a difference there? And the first experiment that one of my students did was use like regular fertilizer, then manure, alfalfa, just to have some residue in the soil and a mixture of alfalfa and manure. And we were expecting to see this effect on seed corn maggot, but actually what she found is in a way the opposite trend, but these differences are not significant from each other. So we don't find a significant difference in seed core maggot presence across these different soil amendments. But as I mentioned before, the question was, does the planting date matter? And this was done across three different planting dates. So the first one starting in April, and we can see that the amount of seed core maggots that early in the season is much higher. So we have around 25 seed core maggots per 10 seed. However, then once they plant after May, there's almost no maggot. It's like less than 1 maggot per 10 seeds, and that's true later in the season. So it's this very early planting that can become a problem. But again, there's no difference between using manure or fertilizer. The presence of the manure will not make the seed core maggot presence higher. So this led to the next question is, how does manure interact with the seed protection treatments? Is there any interaction at all? And so this is another experiment that was done at 3 different farms. And the way this experiment worked is there was our fungicide treatment with a part of the plot with no manure and part of the plot with manure. Then a diamide treatment, an untreated part, like completely untreated, the neonicotinoid, and another fungicide control. And we find in this case that the number of seed core maggot is higher in fungicides and untreated in comparison to a diamide use or a neonicotinoid use, but that the presence of manure does not necessarily make a difference, which is extremely important in our case. And again, the amount of seed core maggots we're finding is extremely low. So these are 5 seed core maggots per 100 seeds. And if we look into stand counts, we don't find a cost of using manure. They are basically the same across all the treatments. So although we see an effect on seed core maggot abundance, we don't see that translating into seed count where there is no difference in between the different seed treatments or the application of manure. So from this, we can say that the abundance of seed core maggot larvae and pupa is very low across the state, that neither cover crops nor manure application appear to exacerbate seed core maggot damage in corn. And diamides and neonicotinoids will reduce seed core maggot abundance, but they provide no advantage in terms of stand counts or yield. And so our preliminary recommendations from this first year of data is that it's safe to continue using manure and cover crops in field crops, but we will be working for 2 more years to continue looking at what will happen. So our overall conclusions and current recommendations are that diamides can reduce seed core maggot feeding, but have no evidence that diamides or neonicotinoids will improve stand count or yield, that cover crops and manure application do not increase seed core maggot risk, indicating that they're safe to continue using in field crops. And overall, we're finding that seed core maggot adults are widespread, but actual damage is extremely low and does not reduce stand count or yield under typical New York planting conditions. These findings align with studies from Canada and Europe, where prophylactic early season seed protection is not needed. The larvae and pupae are extremely rare, and we need more data for early planting seasons where we have wet and cold conditions, which are the worst case scenarios and where the risk of damage is the highest, we think. So again, we're trying to address that this coming season. And so we know that some growers are reporting very early stand losses. We did not capture those in our trials, but from those few reports we have, as I mentioned, we have 5 reports, the prophylactic seed treatments did not appear to prevent the damage by seed core maggot. So when we have these cold and wet conditions, we're not seeing a benefit of the neonicotinoids. So what we are going to do next is we're going to continue with these large-scale experiments and local management experiments for at least 2 more years. And what's important in this case is that this acre that has no neonicotinoids will continue having no neonicotinoids. So with the growers, they agreed that for 3 years, those plots will have no neonicotinoids, just in case we see an effect over time. We want to add diamides to some of the large-scale field experiments just to see if the diamides could prevent the damage by seed corn maggot. And we will be testing seed treatments under different moisture and temperature conditions just to see if they will give a protection in that early wet spring. So I want to thank you for your attention. Again, I want to thank the team. This would not be possible without the help from so many people. I want to thank the growers that have allowed us to work on their farms, and I'm happy to take any questions.
Thank you so much, Dr. Poveda. That was very interesting. So we will transition now to Dr. Heather Darby's presentation. If you do have questions, please feel free to put those in the chat. And once Heather is done with her presentation, we'll start answering some of those questions.
Okay, can you hear me, Kelly?
Yes.
Oh, that's good. Okay. I want to make sure we have time for questions, and there are some things like additional work that we've been doing in Vermont. A lot of the work we have been doing is very similar to what Cornell has been doing. And in many of those cases, we're seeing exactly the, sort of same trends. So I think I'll go through that kind of fast and get to some of the other stuff that we've been working on to be a bit more additive. But similar to what Katja, Dr. Poveda was just saying, we have also been looking at seed corn maggot pressure, wireworm pressure, and white grub pressure on farms throughout Vermont. And we've done this for a few years. This year, we worked in 14 fields plus research farms, so 15 fields in Vermont. And we used the same exact protocol that Cornell was using so that we could begin to sort of match up and share our data. This was a really tough year, as I think everybody knows, to get these trials in the ground because it was so wet this spring, and we had a lot of issues on that front. And I can talk about a little bit of that, but same methodology, same strategy, same assessment as what Cornell is doing. When we looked at germination rates at the V1 stage, we also, because corn was planted so late because of the weather, we did see actually a slight difference between the fungicide only and the fungicide plus neonicotinoid germination rate. Both were very high. There was a significant difference, but again, really no issues here as far as poor stands. Because again, most of the planting was done pretty late. And then we saw no significant difference in soybeans. As far as damage rate goes, we didn't see any significant difference between fungicide and neonicotinoid only in corn or soybean. I mean, they sort of look different, right? The bars are pretty different, but there were no significant differences in pests. We did have some pretty strong wireworm pressure and grub pressure on a few of the farms in our study, but overall, you can see we didn't see any seed corn maggot or wireworm in soybean. We saw more white grub. And then in corn, we saw very little damage overall from any of the pests. And again, no difference between seed treatment. Okay, yields. So this looks bad, right? It looks like those bars are really different, but the difference here wasn't significant, and the scale of that yield should probably be fixed a little bit. So what I want to preface this with is that we ended up having to exclude 3 farms from the yield data. The issue we had, again, we had 1 acre sites next to each other on each farm. With the extremely wet weather and then dry weather, we had in some of the fields like these huge wet areas at one point. The unfortunate thing was that a lot of the issues we had from weather was in the fungicide neonicotinoid acre areas. And so at the end of the season, looking at the yields, we ended up excluding those farms, and overall we didn't see any difference between the treatments. But I did want to preface that we had to exclude some of the data because of that weather related issues. In soybeans, we also didn't see any yield difference between the farms treated with neonic or not. So very similar to what Cornell is seeing there. But again, we're in our first year of data. What I think is interesting that we need to dig into more now that we've started analyzing the data is the fact that there were a few farms that had exceptionally high wireworm and grub pressure. And we want to dig into those farms a little bit more because as we're trying to assess risk, across 50, 60 farms, we may not see a difference in the treatments. But if we're trying to figure out where we do see differences and where risks exist, we have to dig into the individual farm data as well and pull out those cases where, and Katja was mentioning this as well, where we are seeing high pest pressure, and if we're seeing differences between neonic treated and non-treated. So we're still in that process. One of the things that we're looking at, and we have been looking at a little bit, is residues in the soil. And so Cornell did this as well. We took soil samples before planting, and then at the end of the harvest season to look at neonicotinoid levels in the soil. And then, of course, we have treated and untreated plots here. And when we started the trials, you can see really there were neonic residues in those soils, and it was irregardless, right? We hadn't put in any treatments into place yet. And then at the end of the season, there was no difference. There were still some residues left at the end of the season. Regardless of if we used more neonic or not. So we are seeing residues in the soil. I've reported on this in past years. And so the hope here is that over time, as we continue these experiments over the 3-year period, that we do end up with untreated areas that also don't have residue in them, because we're not entirely sure with residues of clethiodin, how that's impacting pests. Interestingly, one of the things I wanted to point out was that farms sort of were on this range of residues of neonics in the soil. So of the 15 farms, there were 5 of those farms that had no detectable neonics in the soil, and the detectable limit was 1.9 micrograms per gram, nanograms per gram. I can't remember, parts per billion. So there were projects or farms, again, that didn't have any detectable levels at the start, and also didn't have any detectable levels at the end. Okay. So again, this is something we need to dig further into. Like, are those the same farms? Is there something about the soil type, the organic matter level? So again, there's a lot to unpack here. When we start to see these, interesting cases pop up, we need to dig into those. And again, we've been doing this for a number of years, where we're trying to look at how long these residues are in the soil and under what conditions do they seem to degrade more quickly. And this is from some research up at Borderview Farm, and this is on a loamier soil. And we've, seen neonicotinoids sort of degrade over time there, depending on the year. So again, just trying to get a better handle. We don't have the answer to this on what's really impacting that degradation. And so here you can see in red in 2023, when we started the trial before we planted, there were some residues in different reps of the neonic, especially a little bit deeper down in the soil. So nothing at the surface, but we went down a little bit and there were some residues there. And this is micrograms again per kilogram. So then 1 year later, okay, same plots, we didn't see any detectable levels. So in this case, we saw that degrade. So what was it about that year? This was the wettest year on record that we've had in Vermont. So, could be related to rainfall, et cetera. So again, trying to unpack this a bit. The other thing we've been looking at is planter dust and management, more so than anything, trying to figure out for any pesticides, actually, because if we're looking at alternatives, we got to keep alternatives from leaving the planter, as well as neonics. Even though there's, a ban going into place, people are still using them and may be able to keep using them into the future as well. So how do we reduce that risk? So we've been monitoring, trying to better understand how this neonic dust treatment is getting off the seed and leaving the planter. Here's our little setup. You can see Kelly, she did all of this. So I have to give her credit. There are these little plates on those little colorful slides you see. And in the first year we did this, we put these at different levels and we're catching dust coming off of the field. The second year, this year, when we did this, we actually were just looking at dust coming off of the planter directly. So a little bit different. In year one, when we were looking at dust coming off from the planter, leaving the field, basically, it was an extremely wet spring that year. And so we weren't creating much dust at all. And we didn't really see much leaving the field. Actually, we only once found detectable levels in the samples we were taking. So clearly conditions at the time of planting have an impact on movement, right? And again, in this particular year, it was wet, there was a lot of moisture, there wasn't a lot of dust, and actually during planting, there wasn't a lot of wind either. And we did this at numerous sites. So, conditions impact movement. I don't think that's probably a surprise, but it's really thinking about how to minimize that. So this year we decided to look at planter types a little more closely. And again, there's no huge surprises here. The Kinsey and the white planter are both vacuum type planters, and the Maximerge is a finger pickup. So if you're in the business of planting corn, you probably know what I'm talking about here. The majority of the planters today are vacuum type planters, and you can see clearly that there's more neonics that leave planters if they're of the vacuum type, right? There's more movement, there's more airflow, there's more generation of dust blowing out of that planter. Now, what was a little bit interesting here was maybe if there are any differences between vacuum planters, and if there are, are there, something about a certain planter, or is it really upkeep on the planter? So again, really trying to dig into this, but you can see that these finger pickups, older types of planters, they produce very, very little dust, and therefore neonics moving off the seed and into the environment. All right, so the other thing we've looked at for a couple of years are fluency agents. And again, past research has shown that fluency agents can be abrasive on the seed and actually pull the coating off, right? Pull the neonic off, and then it sort of gets, it becomes free, and then it moves up through the vacuum out of the planter. So once that coating is off of the seed, it can be lost potentially into the environment. So again, there was some like minimal work done in the Midwest trying to look at alternatives. If you're not familiar, fluency agents are often used to help the flow of the seed through the planter. So one of our questions was, do we get as much dust if we're not using a fluency agent? And are there alternatives? So we set up an experiment at the research farm to evaluate this. We also looked at different seed companies, different brands, to see if there was a difference there. Here's a close-up where we're basically collecting. You can see this like white bag, that's a vacuum bag, and inside of it are those same plates, and we coat it with this sticky material. And the goal here is to collect all the dust that would otherwise come out of the planter, but collect it into this vacuum bag, and then measure what's coming out of it, out of the planter. So we did that. We use these fluency agents. The Bayer product is an alternative, and this product actually called Dust, which is a soybean-based product, is an alternative as well. And then commonly used agents are graphite and talc. One of the things that we've shown over the past couple of years is that this Bayer product, and I think I'll just focus on that, the Bayer product, which is like a waxier product, works really well. And it actually substantially reduces dust in general. So it was even better than having no fluency agent. And I think this is really, really important that with a fluency agent or without, we're still getting dust. But when we added this Bayer product, it did substantially reduce it. So we did this again in 2024. I'll show you some of the data. The little bit of issue we're trying to work with the 2024 or 2025 data is that the lab used a different piece of equipment to analyze the data. So, the units are different. So we have to work through that. But really, overall, the results are the same, but the scale is a bit different. We did see differences between seed brands, right? So here we have a red brand and a green brand, two different seed companies, same neonic being used on the seed, but different companies. And we did see a difference between the companies where the seed treatment itself seemed to come off easier with graphite and talc compared to a different seed brand. This is really important. I think this, again, brings up opportunity to reduce the impact that we're having, a best management practice, and really something to dig into with the seed companies, how they're treating that seed. How are they sticking, right, that coating on? And, clearly here it looks like some of the companies have a better adjuvant or glue or whatever they're using. And again, this Bayer product really seemed to reduce the dust regardless of the company. So that's really positive. Here's some pictures, of what those plates look like once we take them out of the planter. And I think one of the things you can notice here, so that Bayer, and this is, this isn't meant to draw any conclusions from, but when you look at the plates from the Bayer fluency agent, you can see how much more clear they are. So clearly there's not as much dust formation coming off of the seed and through the planter with this product. So again, something we really need to look at. I mean, you can look at the graphite, you can see it blowing out of the planter. So if that has any neonic with it, then it's coming out of that planter. So anyway, I think something, really positive here. Now, this is interesting. We've also been looking at tilled systems and no-till systems, manure, right, in till and no-till systems, and cover crops and till and no-till systems, similar. Looking at some of these things Cornell is also looking at. We've only had this at one site, and it's been at the research farm. Our goal here is to replicate essentially practices that are being used here in Vermont. We still have the majority of our fields that are, fully tilled in the spring. And we also have manure going on those fields at the time of tillage. And then we also have a strong adoption of cover crops. So what does this mean for seed corn maggot pressure? And we didn't see any difference between cover crops in 2024, similar to what Katja saw. That was really different this year. And I'll show that in a minute. And really, I think some of the difference had to do with the volume, with the amount of biomass. The cover crop stand that we had in 2024, I would categorize as marginal. And then the cover crop stand we had in 2025 was substantial. Lots of material, I would say it was probably about a ton of dry matter per acre being fully tilled into the field, in addition to 7,000 gallons of manure, all worked in early. So we planted early, and then planted not immediately after application and tillage, but within days. So trying to set up a risky situation. In 2024, again, we did the same thing. We didn't see any effect of cover crop in this situation. However, we did see an impact from tillage and manure. And this is just looking at the probability of damage. So similar to what people are seeing, what everybody's seeing at Cornell, is that we didn't see any yield declines. We didn't see any impact on yield. More of the impact we were seeing between no-till and till, really related to those production systems, not related to pest damage or stand damage. But the probability of seeing seed corn maggot was higher when we had tillage and then when we had manure. So again, the probability does not equal crop failure, right? It's just saying the chance of seeing seed corn maggot damage is double when you have tillage and you have manure. So this year we looked at probability and percent damage as well. So this is the probability of seed corn maggot damage, and it was highest in tillage, manure, and cover crop systems, and quite higher. So again, this is the probability of seed damage. And in this year, it was even higher than last year, and likely because of the conditions that were out there and the amount of cover crop biomass. We didn't see any impact from cover crop last year. Again, we didn't have much there, but this year we had a lot. And then combination with manure and tillage really seemed to increase, again, the probability of risk. That declined substantially, especially when you go to a no-till system. So no-till systems seem to be less risky, far less risky than tillage systems. And here's a percent of actual damage that we saw. And again, these are in, micro plots. They're not the actual corn plots that we're going to harvest. But you can see we did see damage to the seed. It doesn't mean the seed was killed or the plant was killed even, but there was damage there. And there's more damage in those combo plots, right? Manure, lots of tillage, lots of cover crop. But no difference in yield. Yield was variable all over the board. And again, good yields overall. That wasn't really the issue. So, similar to what folks are seeing at Cornell, we're not seeing yield we're not seeing yield hits, but we are seeing increased risk when you use some of these practices. We have also looked at alternatives, and we're going to continue to do this, mostly focused on diamides. And similar here, we're going to put out larger acreages using diamides and or neonics next year. But again, we're putting this seed out when conditions are conducive for damage, which is, cool, wet, and early season. So this particular plot was planted, I think it was May 7th. It was wet, it was cold, and you can see that the seed treatment made a difference under those conditions. Now, had we have waited another 3 weeks, who knows? But under the cold conditions, we do see an impact. So I think timing has, as Katja was saying, like when field conditions are conducive, possibly we're seeing more of these pests. But again, does that translate into yield losses is really the question we're looking at. We only have 3 minutes left, and I want to leave time for questions, but we have done a planning date study, and I'm going to skip through this to get to this year. This is 2025, and we planted in April all the way through June. And you can see there were only 2 times where corn populations were significantly different between the treatments, and only 1 time where the neonic treated seed had a higher population than the fungicide only. And that was on the 5th of May. And I would say our first flight, and we know this for seed corn maggots at this site, is at the end of April, beginning of May. So it is, in line with, a peak flight and conducive conditions. So maybe not surprising that we're seeing an effect there. But yeah, I think I'll end on that so that we have at least a few minutes for questions. And yeah, sorry for that rapid fire.
That was great, Heather. Thank you. Yeah, so again, if you have questions, please pop them in the chat. I don't see any currently. But we are definitely, I think, both Vermont and New York, we're looking forward to continuing these studies on the acre size scale, just to see if we're going to be seeing differences over, with pest pressure and neonic levels in the soil over the next, now 2 years, because 1 year is complete.
I actually have a question for Heather, since nobody else. So first, thank you. This is amazing just to see like how many things are very similar, which is great.
Yeah.
I was very interested in the till because that's something we're not doing, and there's not a lot of growers here that do no-till.
Yep.
But it seems to work so well. But then in 1 year you had like till plus manure increase the probability of seed corn maggot damage, but then the next year it's kind of the opposite. And I'm just trying to, do you know why the manure and the no-till?
I don't know. It's interesting because in the first year we actually saw no effective cover crop, and it seemed obvious to me that, well, there wasn't much there. Right. So probably that was the reason. And we saw more of an effect of manure in that year. And then this year, we actually saw what appeared to be more of an effect of the cover crop. The manure source was the same. The timing of how we did things and the order of operations was the same. So I'm not entirely sure either. I think we've got to, we got to collect more years of data. It does seem like there's something about the tillage combined with freshly decomposing organic matter that may make a difference. I don't know.
But yeah, then in 2025, because there's the no-till manure and cover crop, and it's the lowest seed corn damage.
Yeah, we don't. No-till, it definitely seems that if you're not tilling, the risk is pretty low.
Mm-hmm.
It's like a combination of tillage with lots of organic matter that seems to be driving this sort of probability of seeing risk. But it seems to me that not tilling the soil and mixing in organic matter, there's not as much risk.
Excellent. Thank you.
But time will tell. We need more data. All right. Thanks, Kelly. I think.
Yeah.
Thank you.
Thank you guys so much. And yeah, Shannon just put up the CCA credits. So if you need them, scan the QR code. Thank you to everybody and the presenters for being here today and being here for the IPM week. We really appreciate it. And if you missed any of the presentations, feel free to visit our YouTube channel where you can find them all. So thank you.
Excellent. Thank you.